Hi, I'm Manuthi. I'm joined by my teammates Joey, Juliana, and Camilla, and we'll be presenting our manufacturing plant design. This project was focused on designing a brand new manufacturing plant for OKKO 2.0 located in Burnside Industrial Park. The goal was to develop a layout that is not only cost efficient and space optimized, but also scalable to meet future growth. Throughout this presentation, we'll show how our layout accommodates efficient material flow, a logical machine setup, and comprehensive infrastructure from warehousing to parking and office space. To design an effective and logical layout for the facility, we adopted Apple's layout procedure, which is a systematic method that emphasizes efficiency and flow. This approach began with collecting detailed data on product demand, machine sequences, and departmental relationships. By analyzing this information, we were able to understand which areas needed to be positioned close together and how materials should move through the facility. Using this foundation, we developed a layout that aligns with the natural material flow and meets space requirements while minimizing unnecessary travel and handling. Our final design not only improves operational efficiency but also reduces congestion and supports smoother transitions between production stages. This ensures both immediate functionality and long-term scalability for the facility. To determine the number of machines required for each product line, we based our calculations on the given daily demand along with machine and operator efficiency, which are both at 95% and a 2% defect rate. These factors were included to ensure our estimates reflect real-world operating conditions. We organized the production into 3 cells. Cell 1 handles product 1 and requires 23 machines to meet its daily output. Cell 2, which produces product 2, our highest volume item, requires 38 machines. Products 3 through 10 were grouped into Cell 3 due to their lower volumes, needing just 16 machines overall. In total, 77 machines are needed across all 3 cells. This setup ensures the production line meets daily output targets while maintaining efficiency and avoiding both equipment shortages and excess capacity. With a calculated flow dominance of 0.2, it revealed that a few dominant flow paths existed, indicating a semi-structured routing pattern. Based on this, we divided the production area into 3 dedicated cells to improve layout efficiency. Cells 1 and 2 adopt a product layout approach, which is ideal for high-volume items with predictable and repetitive movement. These cells were designed to support streamlined movement and minimal handling. In contrast, Cell 3 required a process layout due to its responsibility for handling a wider range of lower-volume products with a more complex and variable movement. To structure this cell effectively, we first applied the Corelap algorithm to group related machines based on flow relationships. Then we used Craft to further refine the arrangement and minimize material handling costs, which ensures a logical and efficient layout for different production needs.
Our office design began with a relationship chart showing how frequently departments interact. We applied Corelap to arrange offices based on communication needs, such as keeping admin near HR and distancing noisy operations from sensitive departments. Beyond office planning, we created a dedicated zone for employees near the production floor. This area includes locker rooms, break rooms, and a first aid room. A cafeteria gives workers a comfortable place to eat and recharge. We also allocated space for maintenance, utilities, and quality control to keep production running smoothly. Every production worker can access a washroom within 200 feet, supporting safety and compliance. Material handling is split into 2 categories. For intercell movement, we use 5 forklifts. 4 transport raw materials and finished products between warehouse and production, and 1 handles stock operations. Intercell handling in cells 1 and 2 is automated via rubber conveyor belts, selected for durability and efficiency. Cell 3, on the other hand, relies on manual handlers, 2 per shift, because of its process layout and product variability. All aisles are 20 feet wide to ensure smooth forklift and operator movement.
We implemented a just-in-time strategy where raw materials are delivered daily and consumed in the same day. Finished goods are stored temporarily before shipment. We used a random storage method since both raw and finished products don't require long-term tracking. The warehouse includes 25 shelving units for raw goods and 17 for finished goods. This ensures we meet daily storage needs while minimizing unused space. Our dock is designed to be compact but efficient, handling both incoming raw materials and outgoing finished products. Based on our calculations, the forklift will make 279 round trips per day, totaling over 11,000 feet in travel. This is feasible within an 18-hour work window and minimizes idle time. We also custom-sized pallets to fit 6 boxes per pallet to reduce the number of necessary trips. The parking lot was designed to meet the needs of all employees and visitors, with a total of 120 spaces. Each module is organized in a 90-degree configuration with walkways in between for safe pedestrian movement. We've also allocated 10 spaces for visitors and 7 accessible spots near the entrance for compliance and convenience.
Based on machine requirements and material handling needs, the facility requires 103 employees per day. This includes dedicated machine operators for the 77 machines, material handlers, forklift drivers, and administrative staff. This ensures all production, logistics, and support functions are adequately staffed. Now moving on to the cost analysis, the one-time investment covering land, construction, and equipment totals just over 7.4 million. Ongoing costs include wages, operating expenses, and amortization of machines and forklifts, adding up to roughly 16.7 million per year. For the cost calculations, we assumed 251 working days in a year and a wage rate of $60 per hour for office employees. Now for the expansion plan, we allocated 20% additional space across the entire facility to support future increases in production or staffing. On the safety front, we included features such as emergency exits, fire extinguishers, and alarms across the facility. And on the production floor, we have additional safety measures like eye wash stations, ventilation systems, and PPE. Moving on to our alternative layout design, it doesn't use conveyors and relies only on manual handling, requiring 30 additional handling operators across shifts. It also changes shipping from daily to weekly, requiring a much larger warehouse to accommodate the inventory. As a result, these changes lead to increased one-time and ongoing costs, making this layout less cost-effective than our other option. We compared both layouts across 5 weighted criteria. The first layout scores significantly higher in initial cost, ongoing cost, material handling, and space utilization, while the alternative is only more flexible. So overall, the first layout is the more cost-effective and practical solution.
And here is a quick overview of our finalized 2D layout. To conclude, this facility design supports OKKO's current production targets while being scalable for future demand. We optimize every aspect, from space planning to cost and safety, making this layout not only functional but also future ready. Thank you for listening. And here is a list of sources used throughout this project. Thank you.